Today, in this video, we will say about isometric projection. This is the last chapter in this current semester of engineering drawing. Now, what is isometric projection, right? So we need to think, we need to understand the concept of isometric projection. But in our earlier chapter, we discussed a concept called as orthographic. So we have discussed a concept called as orthographic. So what we have done, first we brush up what we have discussed in last chapter and how it is correlated with this particular chapter. First we need to understand that carefully. Now if I take a cube, right, this is what the cube, right, this is what the 3D model in other words. If I keep an arrow towards this direction saying this is my front view, now whatever I see in my front view that I will be representing here, and whatever I see in the top view that I will be representing here, and whatever I see from this view that as I am standing here, left side will be drawn on right side of the diagram. This we have discussed in our last chapter, which is orthographic projection. Now you forgot about all those concepts. What we have exactly done, you remember that. What we have done there, we have done converting a 3D object into a 2D entity, right? That is what we have done. Now converting a 3D object into 2D is what called as orthographic, and the vice versa, that is converting a 2D entity into a 3D model is what called as isometric projection, right? If you are getting it or not, I revise one more time. Converting a 2D entity into 3D entity is what called as your isometric projection. Not only that, what is isometric is, isometric projection is a projection in which you can see all the three views of an object simultaneously. That means, you see, for instance, if I draw a particular cube like this, so I am drawing a cube again. So why always draw the cube is, it is very easy to understand. That is the reason we draw always cube. Now you look at here. So this is the front view of the object. This is the side view of an object. And this is the top view of an object. All views. See, I am observer and you are also an observer. What we are seeing on the screen right now, we can see simultaneously the front view, top view, side view of an object simultaneously. In other words, a 3D model, a 3D structure we are just visualizing. So we call this part as isometric projection. So that is what exactly you need to understand the concept of isometric. Now, in order to understand this particular concept, right, we have a couple of structure. Right, this is what the cube which I drawn just now. You just please observe that. Now you look at here. Now, when an object is being rotated, when the object is being rotated with its base, right, base edge inclined to both the plane, right, inclined to its base in both edges point of view, right, like this. Now the object you can see is what isometric view. That is, you can see front view, top view and side view of the object simultaneously. Now that is the reason iso, the word iso represents equal, metric represents units. Metric represents units. Isometric means equal units. That means the object will be visualized by rotating equally, right, with respect to its base. If we do like that, then we call that as isometric projection. Right. Now, before we go further, first we need to understand the terminology for isometric. In Viva, you may be asked, what are the terminologies of isometric projection? Now, if you look at this line, right, the CD line is my x-axis, right, CA line is my y-axis, and you have CB line is my z-axis. So in other words, it is looking like this. So this is my x-axis, this is my y-axis, and this is my z-axis. Now the lines which are parallel to this, that is to CD, I have AH is also parallel, FA is also parallel to ZC, and I have AC as usual. Now the same axis can also be represented like this. The same axis can also be represented as F, H, G and C. Right? The same can be represented like this. And as these are the axes of this particular cube, we call that as isometric axis. So what are isometric axes? Right, these lines which are forming the axis point, we call that as isometric axis. And the plane which is forming right here is called as isometric plane. You see, this is an isometric plane, this is an isometric plane, and this is an isometric plane. So these are all isometric planes which we must know. Now the lines which are not parallel to the axis, see for instance in the terminology again, right, if you check out here, isometric lines, we just seen the lines which are parallel to isometric axis are called as isometric lines, and the lines which are not parallel to isometric lines, right, those called as non-isometric lines. See for instance, if you look at here, the lines which are parallel to isometric lines, say for instance I am saying this is isometric line, this is axis, this is axis. Now for this is a parallel line, for this is a parallel line, for this is a parallel line. The lines which are not parallel to these axes, those we call them as non-isometric lines, right? So those are called as non-isometric lines. Then we have isometric plane, which we have discussed. Non-isometric plane means the planes which are not parallel to isometric plane. So those we call as non-isometric planes. Then finally we have origin or the pole point. Now again, when we talk about origin or pole plane, right, you need to understand here. So we can say this point is the point of intersection of all when you are taking in this way, or you can also say this as your base pole point when you are taking the axis in this way. So whichever the way you take, based on that your origin will be dependent. So this is what the basic terminology for your theory part, right? And apart from this, we have one more important concept called as isometric scale, right? This is very, very important. What is isometric scale? In our earlier chapters, scale, we used to use a word called as scale. So 1:1, 1:2, 2:1, 3:4, like that. So we call them as a scale. Now what is the purpose of this scale is it reduce or enlarge types of scales. Again we need to go to the first chapter where we have enlarged scale, we have reduced scale, and we have normal scale, right? So based on that particular parameter, these isometric scale are also in the picture, right? The proportion by which the isometric lines get foreshortened in an isometric projection is called isometric scale. That means, see, it is very, very important. Not all the things we can draw with respect to the true shape. See for instance, I have a 1000-meter line is there. I have 1000-meter line is there which I want to draw on a 20 mm paper. Is it possible to do it? No. So for that what I will be doing is I will be shortening it with respect to equal square. The same thing we will be doing it. Now in order to do that, right, how this isometric scale will be measured? So the further there is a principle, right, you just check out the picture here on the screen, right? We have isometric scale here. Now what is this isometric scale is, when I inclined with the 30 degrees, right, both the directions like this. So if I say this is base, 30 degrees towards this direction and 30 degrees here. Instead of doing 30, if I take 45 and if I transform the length, right, if I divide it each and every length and transform it, the ratio, if I take it, cos 45 by cos 30. So cos 45, what is the value? Divide by root 3 by 2, right? In other words, you will be getting 0.8165, the value. So that means isometric scale is 82% of approximating. That means what we need to do is, if they ask you to find the isometric projection, right, then you need to multiply the true length with 0.82 times. That means, see, it sounds funny, you will understand straight away now. Here you take this as an example. See, I have given this as a question, right? This is my orthographic projection and I asked you guys to draw the isometric view of it. Now normally when I ask it, first straight away what you will do, you will draw a line, you keep a point in one area, and 30 degrees you draw a line, 30 degrees you draw a line. On the same and the point at where it been intersect, you draw a perpendicular like this. So axis I have drawn it. Now once you finish off it, now what is the length they given? 40 they given, right? So with that 40, I need to just draw a line of 40. Then again you need to keep your scale perpendicular, draw a line 40, then you finish off it like this. And again you need to draw in this area, you finish off it, and finally you finish off cube like this. In all the 3 dimensions you will be doing, right? If they ask you to draw the isometric view, this is what it. But if they ask you to find draw the isometric projection, this is where important point is. Now the important parameter is isometric projection. When they ask you to draw the isometric projection, then you need to shorten the true length. That is, you need to multiply 40 with 0.82. Right, if you multiply 40 with 0.8, right, you will be getting some 38 something approximate. I'm telling you, I'm not pretty sure, so I'm giving 38. So you need to draw a 38 length, and by doing so what happen is there will be shrinkage, right, in your isometric view. To compare it to your isometric view, you will be having shrinkage in isometric projection. So please ensure in the question where they ask you to find the isometric view or isometric projection. Based on that, you need to draw the diagrams. Let's start drawing the diagrams straight away.